Okay, today we're going to be talking about how to use trigonometry to solve a variety of problems. And so the first one is pretty simple. You have a lighthouse here, and you have some sort of boat that is some distance x from the base of the lighthouse, and you have an angle of depression. Now let's talk about that for just a moment. The angle of depression is oftentimes mistaken for this top angle here inside the triangle. But the angle of depression is actually the angle outside of the triangle, which means the angle of elevation is the same as the angle of depression because of alternate interior angles in geometry are congruent. So from now on, when you see the angle of depression, you have the liberty of writing in the angle of elevation. So let's go ahead and put that right here. This is the angle of elevation, and that goes right there. Okay, so with that information, it says we want to find the distance x from the base of the lighthouse. Well, we have the opposite side, and we're looking for the adjacent side. So we can use tangent, but I'm actually going to use cotangent because I want the variable to be on my numerator. So I'm going to say cotangent of 6 degrees is equal to adjacent over opposite. Now I can multiply by 130 on both sides, and it's going to cancel out, and that's going to leave me with 130 times the cotangent of 6 degrees equals x. And so when we plug that into our calculator, x is going to be approximately 1,236.87. Looks like our units are feet. And so this one's pretty simple. Very simple problem. Okay, for the second problem, we have a 100-foot tall building, and we have a man who is observing a car moving towards the building. So the man is on top of the building, and he's observing a car that is moving towards the building. And the angle of depression of the car changes from 22 degrees. So the first time he sees the car, the angle of depression, which is up here, 22 degrees, which means the angle of elevation is also 22. And then it changes to 46 of an angle of depression, which means the angle of elevation is also 46. Once again, alternate interior angles are congruent. And we want to know how far does the car travel. So we're looking for x, how far the car travels. So first thing we have to do is we have to recognize that this is two different right triangles. I'm going to outline them, and the first one I'll outline is the bigger one. And so we have this right triangle here. It's the bigger one here. And then we have I'll do this one in red, we have a smaller one. So those are the two triangles that we need to work with. So the first triangle, I'll tell you what, I'm going to call this distance, I'm going to call this distance here, I'm going to call this distance y. All right, I'm going to create a new variable, and let's call that distance y. So I need to find the distance from the car to the building, and then I need to find the distance from the second position that the car was in to the building, which we'll call that D. And obviously we need to subtract those so that we can get x. So let's see if we can do that. We're going to focus on the gold triangle here for just a moment. And we will say, well, I'm looking for my adjacent side, y, and I have my opposite side, so once again, tangent. So I'm going to say cotangent of 22 is equal to my adjacent side, y, divided by my opposite side of 100. So I'm going to multiply both sides by 100, and I'll get 100 cotangent of 22 degrees. Now I'm going to focus on the red triangle, and I'm going to do the exact same thing. I'm going to say cotangent of 46 degrees is equal to adjacent D over opposite 100. So D is going to equal 100 cotangent of 46 degrees. So in order to get x, I must take the entire distance y minus the smaller distance d. Now remember, the trigonometry can only work on right triangles. So that's the reason why I had to focus on the gold triangle and then the red triangle. So if I do 100 cotangent of 22 degrees minus 100 cotangent of 46 degrees, I will get 150.94 feet. And that represents the distance that the car moved from the first time that the man on top of the building saw the car and the second time. Okay, in this third problem, we have a large helium-filled penguin that is moored at the beginning of a parade route awaiting the start of the parade. You have two cables attached to the underside of the penguin, making angles of 48 degrees and 40 degrees with the ground. So we want to figure out how high above the ground the penguin is. Now, students tend to oftentimes not know where the angles are going. So just remember here, if this is a 48-degree angle, that's a steeper angle than 40. 40 is a flatter angle. So that means we need to have the 40-degree angle, which is your flatter angle. That needs to go here. So we'll put 40 right there. Actually, let's make it a little bit nicer. 40 goes there, and then 48 will go right there. Okay, so now that we have our angles properly labeled, we'll call this X, because we don't know how far away this cable is to the building, and we also don't know the height of the penguin, so we'll label that Y. Okay, so once again, we're in the same boat. We've got two right triangles. So we're going to start with the bigger right triangle. We're going to say tangent of 40 is equal to opposite, which is y, over adjacent. Now, adjacent is going to be x plus 10 because we're dealing with the bigger triangle here. So x plus 10. Then you have tangent of 48, and now we're dealing with the second triangle, and that's just going to be y over x. So if I multiply both sides by x plus 10 here and x plus 10 here, then this is going to cancel, leaving me with x tangent of 40 degrees plus 10 tangent of 40 degrees equals y. Over here, I'll multiply both sides of this by x, and so I'll get x tangent of 48 equals y. Now, because they both equal y, I can set these two equations equal to each other. That one will equal this one here. All right, so let's see if we can go ahead and do that. So we'll have x tangent of 40 degrees plus 10 tangent of 40 equals x tangent of 48 degrees. So now we need to get all the terms that have x on the left and all the terms that do not have an x on the right. Simple algebra here. So x tangent of 40 minus x tangent 48. And I'm going to now subtract the 10 to tangent 40, so that's going to move to the other side. And then I'm going to factor out an x here because they both have an x. So I'm going to factor out an x. That's going to leave me with tangent of 40 degrees minus tangent of 48 degrees equals negative 10 tangent 40 running out of space. And actually, that's all it's equal to. So now we're going to divide all of this on the other side. So x is equal to negative 10 tangent of 40 divided by tangent of 40 minus tangent 48 degrees. And we plug that into our calculator, we will get 30.905 feet. Now, many students will stop there because they've done a lot of work. But remember, we're looking for the height of the penguin, so that's the letter y. And earlier, we found that y is equal to x times tangent of 48. So we need to take this answer We need to plug it in here for x. So our y, which is our final answer, is going to be 34.23 feet. Okay, here we have example 4. We have a U.S. Coast Guard patrol boat leaves Port Cleveland. So here's Port Cleveland. We'll represent that with letter A. It's going at a speed of 35 knots, which basically means 35 miles per hour. It's traveling for 2 hours on a course. Now, we need to focus our attention on the word course. Course is another word for bearing. Bearing, and this is something brand new for you, bearing is measured from the north, rotating clockwise. Rotating clockwise. So when you see the word bearing or course, then you know that you have to measure the angle with a different method. You're starting from the north, so you would start from an angle of 90 and you'd rotate however many degrees clockwise, and that would be the direction that the boat or the plane is going in. So for simplicity purposes here, let me just draw this triangle again here. So we have this, and then we have the 90-degree angle here. Okay, so now let's go ahead and label this triangle. So this is going to be our right angle, and this we see is going at a course or a bearing of 53. So that's why the 53 degrees goes here, because you're measuring it from the north, from 90, you're measuring clockwise. This is 53. And it's going at a speed of 35 miles per hour for 2 hours. So that means that this side of the triangle is going to be 70. All right, 70 miles. And then the boat turns. So let's go ahead and reorient ourselves. So we'll call this another north and south there. So the boat is now going to turn, and it's going to go at this same speed for 3 hours. So 35 miles per hour for 3 hours is going to be 105 miles. Now, it wants us to tell them the boat's bearing and its distance from Port Cleveland. So this is where the boat ends up right here. We need to find the distance from where the boat ends to where the boat started, which is Port Cleveland. Okay, we'll just call that PC. So this is the side we're looking at. So all we need to do is just do Pythagorean theorem. So 70 squared, let's go ahead and do that. 70 squared plus 105 squared equals c squared. And so whenever you solve that out, you'll get 126 point, looks like 19 miles. So the first part of the problem is done. Now we've got to find the bearing. This is where it gets a little confusing. We need to find theta, because if we can find theta, then we'll be able to find the bearing. So let me outline the bearing for you. The bearing is measured from the north, and it is rotated clockwise until you get to the direction that the boat has ended up at. So we need to find this entire angle. But we already know this angle is 53, so all we need to do is find theta. Now let's think about what we have. We're looking for an angle, question mark. So anytime we're looking for an angle, we need to use our inverse buttons, our inverse relationships. So we'll say theta is equal to the inverse tangent of opposite, 105, over adjacent, which is 70. When we do that, we'll get theta to be approximately 56.3 degrees. And once again, many students will put that answer down, not realizing that's just theta. We must measure from the north clockwise because it says what is the boat's bearing. So we must add 53 degrees to that answer. And when we do, we'll get 109.31 degrees. And that is the boat's bearing. And this is the boat's distance. So let's go ahead and box both of those answers in. Okay, we're going to skip example 5 and move on to example 6. We have a mass that is oscillating up and down on the bottom of a spring, and it can be modeled as harmonic motion if the weight is displaced a maximum, there's your key word, a maximum of 5 centimeters. Find the modeling equation if it takes 2 seconds to complete one cycle. So we see that the period is 2 seconds. And it doesn't tell us where the spring starts. It doesn't tell us that the spring starts at 0 or at the max or at the min. So therefore, we have our choice whether we want to use sine or cosine to model this situation. So I'm just going to use cosine. So we'll just assume that maybe it starts at the bottom. So the maximum or the amplitude is 5. So I'll say y equals -5 cosine. Once again, you may say +5 and have it start at the top. That's totally fine. Now we've got to find our b. So the period is 2 pi over b, and that equals 2 over 1. I'm going to cross multiply and get 2b equals 2 pi. And cancel off the 2's, and so b equals pi. So basically, we have -5 cosine of pi x. And I guess you could say this would be t to be technical.